Hello, everybody! Happy National Fossil Day! I am so excited to welcome you all to the episode 2 of our Let's Tour live stream event. Today, we are going to be visiting the John Day Fossil Beds National Monument. So, for the Let's Tour live stream event, we are visiting all these really cool national collections and asking the question, why are museum collections important? More specifically, why are national collections so important? When we visit our amazing national parks and monuments, we think of the beautiful landscapes and wonderful outdoor experiences. But many of our parks and monuments are also home to some incredible fossil collections. This week, we are going behind the scenes with their scientists to learn more about these collections and why it's so important to preserve them and the lands that they are found on. The purpose of the John Day Fossil Beds National Monument is to preserve and provide for the scientific and public understanding of the geological and paleontological resources of the John Day region. The Monument's museum collection includes both natural history and cultural collections. The natural history collection emphasizes paleontological and geological specimens related to a span of nearly 50 million years within the John Day region from the Age of Mammals and includes vertebrate, invertebrate, plant, and trace fossils. And I am very, very excited to welcome Dr. Nick Formoso. Hi, Nick.
Hi, Gabe. It's great to be here. I really appreciate you putting these on and having us here. And I'm also joined by one of my colleagues, Amy Atwater, who's behind the scenes, making sure that I'm in the frame. So it's all good.
Well, hello, Nick. Hi, Amy. It's really great to have you both on our Let's Stream today. Or Let's Tour live stream today. It's still a
Yeah,
little early
absolutely.
for me, so just give me a second to catch up.
No worries.
So, what are you going to be showing us today?
Yeah, so today we're going to be looking around the museum collections here at John Day Fossil Beds National Monument. Yesterday, you had a great opportunity to see the quarry wall at Dinosaur National Monument. We unfortunately don't have like brilliant fossils that are super easy to see out in the field where we also have good internet or phone conductivity. So we were going to do stuff here in the exhibit, or sorry, not in the exhibits, in the collections. If you do come and visit John Day Fossil Beds, you'll have an opportunity to visit our beautiful exhibits out on the front, which will show you a lot of wonderful specimens. But I've got some cooler ones that you can't see out in the gallery. So this is kind of the cool sneak peek behind the scenes view of what we've got here.
That's so cool. I'm really, really excited. And
Yeah.
as a person who is very partial to mammals, I am
Woohoo.
a little bit more excited to see these fossils. Nothing wrong with dinosaurs. Don't get me wrong. I mean, the dinosaur wall was really cool, but
Yes.
mammals is where it's at. I'm just saying.
Absolutely, absolutely. I've been a mammal person since I was a little kid, so I'm also like right there with you.
Awesome. All right. Well, as Nick takes us around a tour of the collections, for those of you watching at home, we will have a Q&A following our virtual tour. So if you have any questions, please type them in the chat and we'll ask them once we're done. All right, Nick, please take it away.
Okay, well, first, before I get going too much, I do just want to mention that we are in the Sheeprock unit of John Day Fossil Beds National Monument. And there are three separate units of our park, the beautiful painted hills that a lot of people in Oregon have probably heard of, or many people have seen pictures of. We've also got the Clarno unit up in the north. And all three units of the park are on ancestral lands of the tribes affiliated with the Confederated Tribes of Warm Springs, the tribes of the Confederated Tribes of the Umatilla Indian Reservation, and the Burns Paiute tribes. So we've got a lot of different peoples that we work with here as well. You know what I'm planning on showing you all today is kind of a walkthrough of what a fossil's life is like. So we saw yesterday those wonderful fossils out in the field. And if you work with mammals, they're a lot smaller, and in my opinion, they're a lot easier to deal with because, like, you know, you can fit 1,000 rodent skulls in a drawer, whereas you can only put like one brontosaurus or apatosaurus fossil, like one femur, one bone from that animal, in a space of similar size. Actually, that's probably not a great comparison, but the idea is still there. So what I want to show you all is how our fossils come into us. So when we're out in the field, we collect them and bring them out from the different exposures out in the park, and we bring them back here to the visitor center. And they come in a couple of different shapes. So the bigger things that we have, they'll come in these plaster jackets like this. So basically what happens is you find a fossil sitting up on the surface, and you say, ooh, that's cool, I'm going to poke around it a little bit. And then you take your tools and you dig around, you find the extent, and then you realize it's too big to just like pull out of the ground. So we create what's called a jacket around it. So what that ends up being is, you know, we dig a trench around the fossil, and then we put this. In this case, this is the same kind of material that you get a cast with. So it's gauze and plaster, and we put that around the fossil. Put some toilet paper on there too, just to make sure the plastic doesn't stick to the bone. And then once it's solid, we flip it out and got this nice little package. And then when we're back in the lab here, back in the building, we can open it up and take a look. And this is just an example. You can't really see fossil bone exposed here, but this is oftentimes what it looks like when you start. So you don't always know what's there, and you got to slowly work down through all the rock until you get to the actual fossil. Um, so that's what we do for bigger things, because although this has been around for, you know, millions of years, um, you know, they're still still very fragile. We end up finding fossils that have been under a lot of rock for a very long time, and so they end up with a lot of little microfractures, and they're a little too fragile to just kind of pull out of the ground. So we often have to do things like this to stabilize them. Um, and that's our big fancy things that we find, right? These are the exciting big fossils that we have. But oftentimes fossils don't come in looking so pretty as this, or as cool, nice little contained package. Oftentimes they kind of come in looking like this. This is just a little baggie with uh, 3 fossils right over here. This is a partial pelvis that came from one of our sites, and a little bit of limb bones. We've also got this one here, which is pretty cool. It's wrapped in toilet paper here. And this is actually some dog material, some dog molars that my colleague Amy found a couple of weeks ago. And this is her first dog, I believe, that she's ever found. So this one is really cool. This is really special for her. And it's, also just really awesome because we find dogs here, and there's quite a few dogs here. But it's just little partial pieces, right? It's not a complete skull, but it's still really informative things that we find like this. It's actually really rare in the Oregon fossil record to find complete things. Most things are scrappy, broken up pieces, and we do occasionally find complete skulls, but it's not always completely there. So that's kind of cool. I'm just trying to see this one, and then this is just another big one, right? So sometimes they're just really big pieces that you just slap, put in a bag, slap a tag in there, and everything's happy and good. This particular one, I believe, is part of an ankle. It looks like it's part of an ankle. We leave the little notes in there so that we can remember what they are and figure it out. It's all part of the taking the notes thing. Because taking notes is really important with all this stuff. We've got all kinds. There's a cabinet over there that I'm looking at that I won't show y'all, but it's just full of notes because those notes are probably more important than these fossils, because honestly, you don't have all that associated information. These fossils might as well just be pretty rocks, right? Because they don't have a lot of context, and we really need to know where they are. It's really important here in John Day fossil beds because, as we mentioned earlier, there's about 50 million years of time, and if we don't know exactly where it comes from, kind of hard to put things into context. There's, in one layer that we work in, there's about 14 different volcanic layers. And we really need to know which volcanic layers the fossil comes from if we really want to know that precise date that it comes from. And I found things, not in our collections here, but things that were collected here by the first Western paleontologist who worked out here. That was Thomas Condon in the 1860s. And some of the stuff that he collected, they didn't know exactly where it was from, so it would just say the John Day Valley, and the John Day Valley is huge, right? There's a lot of time, a lot of stuff in there. It's really hard to pinpoint things, so it's not always the most accurate information. But so one of the other things I do want to show you before I get too far down that rabbit hole is with these jackets, we do also use specialized tools to remove the rock from around these fossils. You'll probably hear a little bit more about this tomorrow. But so this is a tool called an air scribe. And so it's just basically like a little jackhammer, and it's plugged into air. And what we'll do is we just go through and we'll slowly remove rock. This one's not going because I'm not in the lab. But that's one of the main tools that we use to remove the rock from around these bones, because the rock here is so hard. It's basically like concrete around an egg here. So it in some of the rock layers, so it can be very difficult at times. But once we've done all that work of collecting the really cool fossils from the field, and then our preparators spend all of their time preparing and cleaning up all these wonderful fossils and making sure that the documentation is all there with it. What do we do next? We bring it into this room, which is the collections room. And if you were here, you would notice that maybe it was a little cooler in here than some of the other rooms. You might notice it's a little bit more humid. And that's because we try really hard to maintain a certain level of environmental conditions to make sure that these fossils and all the notes and everything else are here in perpetuity. That's the whole thing with a museum, is we're here to keep things around until the end of time. It's one of the big ways that paleontology is a repeatable science, because I can go back to look at fossils that were published on 100 years ago at a museum, and I can say, hey, look, that's the same fossil that Marsh published on in 1890 something, and oh, it doesn't look anything like what he described, which happens more often than you'd think. Or it looks exactly like how it was described, and that's one of the cool ways that we can make sure that all that happens. Now that I've explained all of that, I'll take you back real quick into some of our cool specimens. So the first ones I want to show you are near and dear to my heart because I had horses from when I was little, and I got really into fossil horses for a lot of my career. So I'm going to show you some of our cool fossil horses because our fossil horses here were part of the whole story with Darwin. Some of our fossils were sent by Condon over to Marsh on the East Coast, and he then said, "Thank you for the fossils that you thought you were getting back, but I am keeping them here at Yale. And then I'm going to write letters to Darwin and tell him I found all these cool fossils that kind of fit in these holes of horse evolution, and it really does show this, the fits in with the story of evolution through natural selection." So one of the things I will show you is this cool skull. All right, so we've got these cool skulls still in a jacket. This is one of our fossil horses. You can see their teeth are very different. If you've ever seen modern horse teeth, they're about 4, 5, 6 times bigger than what you've got here. But you've got the eye socket up here. This is the little snoot up here. Its little nose would be here. Lower jaw, upper jaw, back of the head over here. It's a really cool fossil that we have here. And they did a really good job of keeping this together considering how busted it is. So that was really good. Good work there. And then one of the important parts of these horses is actually with their feet. So one of the things that's different is, and this is a cast of a specimen, but this is the main toe, the center toe, and it's got a side toe here and a side toe here. So this was a 3-toed horse, and this is the most common horse that we find in the John Day fossil beds in the green layers that we have. And that's, the really important thing because the horses before this, 4 or 5 toes, horses after this, eventually evolved into the single-toed horses that we see today. In fact, modern horses today still have these bones as split bones behind that cannon bone. So they still have remnants of their 3-toed ancestors, which I think is really cool that you can see that. And there's a few other features that we use to describe, to know that they're horses. I'm trying to think if there's anything else that's cool in this particular one. I don't think I will in the horses, but horses are very cool and important here at John Day Fossil Beds. And I think another one that I'll show you all, which is a very popular Oligocene animal. Oligocene is a period of time. But this is our cabinet of even-toed ungulates. So ungulates are hooved animals. So this is the even-toed ones. So these are relatives of camels and sheep and pigs and other things like that. But one I'm going to show you, because I kind of teased it in my photo, is this jaw right here. This is the jaw of an entelodont. This is a big pig. Well, it's like a pig. It looks a lot like a pig. It may be more related to things like hippos or whatnot. I mean, it does actually have a lot of very similar features to hippos in its jaw structure. They have a lot of these, not on this particular jaw, not very many, but there's like this big bulb bit right there, big process that's sticking out, and these teeth are massive, right? I mean, this is my hand here, and you can see just how big this canine is, right? That's a huge canine. And if you look back at the molars, they don't look that much different from ours, right? And we're omnivores. And so that's one way that we know that these animals were also omnivores. But this is an animal that was just running out on the landscape out here, one of the biggest animals here. And it was just kind of doing whatever it wanted out on the landscape. I'm sure it could eat whatever it wanted, whenever it wanted, sort of deal. The only animal that would have rivaled it in size were the rhinos that we had here at the time. Oh, man. That's a really big one. Let's see, what else we got? 2 other groups of animals I want to make sure that I show you guys today are also carnivores. So one group is our false saber-toothed cats. So we have a very long history of feliform things, which are animals shaped like cats. And we've got quite a few here. This is a really cool specimen that I love to show people. This fossil actually comes from Bureau of Land Management land, which we do have a lot of collections from from BLM administered lands. But this particular one is a skull. So I'll show you a side profile here. So you've got the eye, the snout here, the little bit is broken off, and then the back of the skull is over here. And we do have one saber tooth. And one of the things, it's going to be hard for you all to see, But if you were able to see really close on the profile here, you'd notice that there's a little divot in the interior side. And that's one of the ways that we know that this is a baby, because, or at least a juvenile, not a full adult, because saber-toothed animals, when they have, at least mammals, when they have their baby teeth come in, they have this little groove on there that allows for the adult tooth to slide next to it, and then the baby tooth kind of pops out the side. And that's one of the ways that we know that this was not a full adult, which is pretty cool. We can see that in the fossil record. One of the other things I think is really cool about this, and we'll see a little bit better with the dogs, is that this back area here, this is where the ear bones would be, and it doesn't really look like they have much in the way of ear bones. Usually you'd see like a capsule there, like a hard bone shell. But we don't see that here. It's open. And I like to ask people, like, if you were here in person, I would say, oh, well, is that because this is it didn't have any ears or it couldn't hear? Like, what does this mean? And ultimately what it comes down to is that most likely these animals weren't using hard bone like we do to solidify the auditory area there. They were probably using cartilage, like what makes up our nose and our ears. And that's something that we see in another feliform animal called the civet that lives today. So that's part of the hypothesis there, is like, oh, well, that's probably what they were doing. That's really cool. So that one is one of our coolest specimens. But another one I really like to show people is this one down here. This is when you look at this particular specimen here, it doesn't look like a whole lot. But what it is it's a skull of an animal called Pagonodon here. And I'll take out one of the sabers. So Pagonodon is our largest false saber-toothed cat. And it is, probably about the size of a small adult lion, right? So it's big, but not like as big as a tiger. And this was the largest one at the time. Now, one of the things I love, right? I mean, this is a huge saber. I mean, it by no means is it like Smilodon sized, right? So you're down in Rancho La Brea, you'll see saber teeth that are way bigger than this. This is the biggest at the time. And one of the cool things that you can see, and you can see here, is that along this edge, you can still see and feel the serration on this thing, right? So this is like a steak knife that was in this cat's face that's still pretty sharp today. So I think that that's a pretty cool specimen. And that you can still feel that. Let me put this one back here. And our most common one, if I can find our most common one real quick. Here we go. This is our most common one, just so you get a sense of the size. This is Nimravus brachiops, and Nimravus is probably about the size of a mountain lion. So that's about the size of our most common false saber-toothed cat that we have here. And if you also kind of look there, you can still see, right? No ear bones, but also those sabers are pretty tiny. And they're serrated. You can still feel them. That's pretty cool. Okay, so now I'm going to go into the last group I'm going to show you all today, which is the fossil dog relatives. And there were, at one point in the Green Turtle Cove rocks, which is about 29 million years ago, there were as many as 10 coexisting species of dog. I'm not going to show you all 10. I'll show you two. Two of my favorites, just to kind of get a sense of the size. So, here you go. Not that one. Okay. This one. Here goes this one. So this is a dog called Mesocyon. Mesocyon is about the size of a medium-sized dog. So maybe like a big corgi or a big dachshund or something like that. Maybe it's a little bit bigger than that. But it's probably like a 30 or 40-pound dog. And this is a really common size that we get around here. They get bigger than this. We have bone crushers as well that are, I guess I can show you this one. That's right here. Bone crushers like this guy. I believe this is Phylotrox or in Hydrocyon. It's one of the two. It's in Hydrocyon. So, I mean, it's a fair size bigger, This is probably the size of my dog, which is a 70-pound dog. But then those two are cool. They're really awesome. But we also get tiny dogs. And the tiniest, probably cutest one, in my opinion, is this guy right here. This is Synarctoides lemur. This is a full-size fossil dog, right? And this is about the size of a chihuahua, the skull here. And if I flip him over here, you'll see these big bumps right here. And those big bumps are actually its auditory bones, which are huge. Here's another one of those anhydrous or uh, uh, mesocyon dogs. And see, like they're not nearly as pronounced in this one. So what does this mean? Well, it probably means that it had gigantic ears, which are pretty adorable. We have a great sculpture on display in our exhibits of one of these animals, and it looks kind of like a fennec fox. It's got these gigantic ears. It's really adorable, and this is probably the cutest fossil dog that we have, in my opinion. But this animal was probably eating fruits and nuts and things. We generally associate this with being like semi-arboreal or something like that. Right, but I mean, it is just super adorable. So we run the gamut here from giant things to little things, um, and yeah, those are probably the special highlights of what we've got here in collections. We've got a lot more, like I mentioned. We've got uh, all kinds of insect. We've got insect eggs. We've got trackways. We've got burrows. We've got little dung beetle balls. We've got birds. We even have a primate here, which is also really cool. It's the last primate in North America before humans arrive, or at least that's the received wisdom that I've had. But yeah, those are just some of the cool highlights that we have here in our collections.
Nick, I I need to see an illustration of that tiny little fennec fox chihuahua fossil thing because that sounds like the cutest thing in the Oligocene I have ever heard.
It definitely is, and I've got my colleague here working on trying to bring up a picture for you because I didn't think to actually bring a photo up for you guys, but it is pretty adorable. It's laying underneath a tree. And what's also really cool about it is that the artist that we worked with, Reed Saltus, he worked with the Oregon Commission for the Blind to make sure that this was a great tactile element that would be useful for the blind community to actually like get a sense of what this animal would have looked like. Um, so it's a pretty awesome project that we had a couple of years ago.
That's
And
awesome.
oh, here he is. Here he is. I don't know how easy you'll be able to see that.
Oh, it's so cute. I
Yeah,
want
it's
one.
it is so adorable, and those ears are probably like the size of my pinky,
That
right?
is
So I mean
so cute.
it's really adorable.
I need to go see some of those things in person. This the skull you had in your hand was so tiny.
I know, yeah, yeah, and like the very front end of it is broken off, so it is a little bit bigger than how it looks there. But I mean that's still like a pretty small dog, pretty small.
So, looking through a lot of your or not a lot, but some of the specimens that you showed us today, it seems like the John Day fossil beds has this really great story from this time period. And how does that fit into like the greater story of like the West Coast of the United States and what we can learn about this time period?
Yeah, no, that's a wonderful question. So I didn't show you any of our oldest fossils, mostly because we don't have a lot of them back here in collections. But our oldest fossils represent a subtropical jungle era from about 44 to 40 million years ago. And a lot of the animals look completely different from what we have today. So we see this transition from the subtropical jungle in the Clarno Formation to these temperate forests starting to show up in the John Day Formation, and eventually towards the end of the John Day Formation and definitely into the Maskell and the Rattlesnake Formations, you see this opening up of the habitat to from like completely forest to forest with meadows to grasslands to what we have today, which is a sagebrush steppe environment. So that's the big thing that we can see here because we didn't really move all that much. So we've got this wonderful record of adaptation to changing climates over that 40, 50 million year period of time, all in one spot. So that's a really great opportunity that we have here where we can see all that. And one of the things that makes it difficult is because we have about 7 different periods of time that we talk about here. it makes it hard to find something that's unique to just us, right? So like a lot of National Fossil Day stuff is like, oh yeah, there are these cool dinosaur fossils up in Alaska, or like agate fossil beds or Hagerman fossil beds, which has very specific things. But it's like, well, we have all the same animals, or most of the same animals, as Badlands and agate and Fossil Butte and a lot of these other parks around the service. And it's often like, well, I mean, all these things could also be interpreted as being one of these other parks, right? So that part is kind of frustrating, but it's also really amazing that we are able to do all that. We're able to see all these things. We see some of the earliest immigrants from Asia come in here to North America also. We see a lot of very bizarre things that you wouldn't necessarily expect here. Um, and there's just so many really cool and exciting things. Some of the earliest brontotheres, which is these thunder beasts, before they spread around, like ours look really blah and boring compared to the ones at Badlands National Park, because none of ours have these like big fancy like I almost call them hood ornaments. They kind of are like hood ornaments.
Yeah, pretty much.
We don't have any of those here. Ours are all like, they've all got flat noses. Our rhinos are like, yeah, I mean, like the fanciest we get is two horns right next to each other, right? So a lot of our stuff isn't like super exciting or different, but we do get a lot of very unique animals here also. But they're, you know, like the Egamua shashala, which is the little primate that we have, right? And that shows up at a very weird period of time because it's not very forested at that time, but it's still here. So it's kind of like, what are you doing here, little primate? Like, kind of bizarre. But yeah, so we can tell all about this. And the other thing that's really exciting about here, particularly in the Green Turtle Cove rocks, is our ability to see, because we have 14 dated volcanic rocks in a 400-meter section, which is a lot. It covers about 3 million years of time. So we've got all those page numbers, and we can tell a lot about how things have changed, rates have changed. The other thing that I personally find interesting is this response to volcanism. How do organisms respond, recover, come back from events like this? Like we've got a supervolcanic eruption that we preserve here that's basically like a Yellowstone eruption, right? We've never seen that in human history. Might as well look at the fossil record and see how these organisms recovered and see like what was going on there in order to kind of get a better sense of what might happen in the future.
That's so cool. I think that's like, you know, for National Fossil Day, we're celebrating the amazing fossils that we have, but it also goes beyond the fossil itself, right? It's the story that we can learn of the past. And for you working in the collection, and what is it like to be able to have like that responsibility of protecting pretty much these chapters of time?
Right. Yeah. No, I mean, it's amazing, right? It's this wonderful opportunity that we have here to take care of all of these fossils all the time. You know, and it's one of the things I really love when we go out and do field work in the backcountry. We find these fossils, and we're the first living things, or humans at least, to see these things in, you know, 29 million years in some cases. Sometimes like those wonderful peccary fossils that we had a couple of weeks ago, 7 million years ago, right? So it's all these different periods of time, and we're the first people to see them, and then bringing them back here, you know, it really, what it does for me is it gives me this real sense of accomplishment, that even though like our lives are finite, right? We're not going to be here forever, but the intent is that these fossils that we put into these museum collections will be here long after we're all gone, right? And to me, like that legacy, particularly of our natural environment, is so much more rewarding to me than, you know, a lot of other jobs that I could do.
I feel you there. I mean, I love working in the collections.
Yes.
I don't get to do it very much that often anymore, but whenever I do, it's so cool.
Yeah.
From that question as well, why is it important that we have like national park collections and national fossils from for a place that we can preserve these fossils from federal lands?
Right. No, that's a wonderful question. And, you know, so the mission of the Park Service in general is to preserve and impair the natural and cultural resources of the national park system, which is just the National Park Service sites, for future enjoyment, basically, right? So, and use. So, like, there's some confliction there because, right, we could just leave them all out in the field, and that's still preserved as long as people aren't coming in and taking them, but, you know, and putting them on their mantle or anything, right? But then putting them in here, you know, is just so important, because we're keeping them around. And the other thing that I'll mention is like every National Park Service site is supposed to have a museum program of some way. Right, so there's like over 400 sites. They all have some kind of museum collections of some kind. Not all of them have fossils. I think it's like 233 of them have fossils. But oftentimes, like, you know, it's important for us to have these facilities so that we can preserve that heritage, that we save that information for as long as possible. And also, it's kind of nice to have them at the Park Service sites. You know, it doesn't always happen that way, but it's nice to have them here because when they're here, if you come out here to do the research, you're actually like kind of among where the fossils came from. It's not always fossils in this case, the whole collection, but you're among where all those things come from. And having that association where things come from is really important. I mean, because it is cool, like, because you can see these fossils in fossils from this area in 16 other museums across the United States and even abroad, which is cool because then like people in New York can actually go and see them. In South Dakota and down by you, the Los Angeles County Natural History Museum has fossils from here that were collected. University of Washington in Seattle, University of Oregon in Eugene, right? And it's great to be able to go and see those places there. And oftentimes if you're doing research, it's a little bit easier to go to LA or Eugene or Seattle than it is to come out to rural Eastern Oregon. But having them here, that means a lot. Right, and it allows for those things to kind of retain some context of where they came from, and that to me is really important. And you know, there was a long time where all these fossils would go to the Smithsonian, and there's fossils of ours at the Smithsonian also, and that's great and wonderful. But it's also nice to have some of those collections where they came from.
I completely agree. Like having that local story as well for people to appreciate the fossils that literally come from like their backyard sometimes. It's just so important.
Right. And that can be lost on a lot of people. They don't always get a chance to learn about what's in their own backyards.
Well, speaking of some of those people, we've got some questions. You ready, Nick?
Cool. Yeah, absolutely.
All right. So the first question was actually from me on accident. I was using the wrong account. But when you were looking at some of the horses, I was wondering, do you have modern horses at the monument? And what's your favorite horse fossil in the collection?
Sure. So we don't have domesticated or feral, wild, however you want to describe it, horses in the boundaries of the park, right? So one of the things I neglected to mention earlier is that the John Day Basin is huge compared to us, the National Monument. We make a very tiny percentage of that. And one of our biggest partners is the Bureau of Land Management, and that's where the feral horses are. So there's actually bands of feral horses that live out on the Bureau of Land Management land around here, and so we do still have some of them out on the landscape. We used to have pack horses here a long time ago, but we didn't really have a need for that program anymore. And of course, there's a lot of people who, you know, this is cattle land out here, and one of the best ways to go out and round up the cattle are on either ATVs or horses. So we see either of those go out occasionally to help round up animals around here. I've got some friends of mine around here that also hobby ride, so there's some of that also. But my favorite fossil horse in the entire collection, I mean, it's an individual specimen, and it's one of those three-toed Myohippus specimens. And it's let's see, I'm going to try and grab it here real quick. There it is. Is this skull right here?
Cool.
It's a very nice, complete skull, but if you are familiar with the fossils, this snoot doesn't really look right. It looks a little bizarre. And that's because they were experimenting, you see it a little bit better over here. They were experimenting with bowling ball material to try and do gap filling in here. So this is all brown bowling ball material that they used to make the front end of this. And then back here, this is also some of that brown, and they also worked in some green. So this is a really just like bizarre skull for that reason, but it is one of my favorites because it is a complete one, and you can see like the entirety of the teeth row here. And it's just a really pretty skull otherwise, with a really cool story of what they were trying to do to make this thing look complete.
Bowling ball material. I have never heard of that before.
Yeah. This is the only place. I worked at a lot of museums in my career, and this is the only place I've ever seen this done. So Just bizarre.
That's definitely an experiment for sure.
Exactly.
All right, so this question comes from Rick Spears, who's asking, is Hesperocyon found there, or is it the wrong time?
We don't have Hesperocyon specifically here at John Day Fossil Beds. That's something that, and I think that that might be more of a like location-based thing. So we definitely do have rocks in that period of time, but we don't have Hesperocyon specifically. That's more of a Great Plains thing. So you find that more like Badlands. There's definitely Hesperocyon out there. So it's
Cool.
just geography most likely.
But we do have hesperocyanines.
Right, but we do have, yes, Amy is correct. We do have members of the larger, I think it's a tribe or something like that of canid subfamily. That's what it is, called the Hesperocyanae. So we do have relatives, very closely related relatives of that. We actually have
Cool.
all three subfamilies represented here also of fossil dogs.
Awesome. And thanks, Amy, for the chime in.
Yes, I would have forgotten. I appreciate it.
This one's
I
from
love dogs.
Jasmine Mossy, who's asking, I heard about a turtle fossil that was found near Foree. Where was it found, and who found it? Was it found in your area?
Oh, goodness. We have turtle fossils from Blue Basin and Foree. They're found all over the place over there. There was one that we recently collected from Foree. I can't get too specific because we're supposed to protect like the exact locations of where they come from. But there was a fairly large jacket of a tortoise that was found over there not too long ago, a couple of years ago, and we collected it within the last 5 years or so since I've been here. So we do have it there, but the Turtle Cove member, which is named for Blue Basin, which at one point was called the Turtle Cove. It's called Turtle Cove because there's a bunch of turtles there. So there's definitely a lot of turtles. And we're talking about turtles that are like shells that are probably like a foot and a half thick, something like that. And they're not like Galapagos tortoises, but they're like big tortoises still.
Heck yeah, I would love to see a bunch of those just roaming around.
Yeah, exactly. If I might actually be able to open up a cabinet real quick and see if I can't get it. Most people don't ask about the turtle, so I didn't, prearrange myself to get this turtle cabinet open. But I'm glad because very few people research turtles, and so it's actually really cool that you asked about that. And I've got two here, three actually. I don't know if you can see how well you can see these. Tip it down a little bit. There we go. So there's one right here, and there's another one here in the back. And so those are our turtles. And then I've got this other one up here I can actually take out. It is heavy. Just kind of give you a little bit more sense of how big these things are. And the other thing I think is cool is we can also tell which ones are male and which ones are female. So you flip it over, and this is what's called the plastron. The top is called the carapace. So you look at the plastron, which is the part right here. And I used to be a competitive sport fencer, and the plate that you put on here is also called the plastron. Makes sense. But if the plastron has a divot in it, it's a boy, and if it's flat, it's a girl. And that's for, I guess you can probably put the dots together as to why. If you're trying to, make more turtles, it helps if you don't roll off while you're trying to make more turtles.
It's okay, Nick. This is a science show. We're fine.
Yeah.
That was so cool. Thanks for showing those.
Yeah.
This question comes from Ed Welsh, actually. If you could, would you be a crazy cat person, but replace the cats with synarctoides, and how many would you have?
So be a crazy dog person. I mean, I already kind of am. I have like 3 dachshunds at home with my big dog. But if I could I would only have like one synarctoides because I'm pretty sure it would be one of those like yappy dogs. And I do love them, but I can only stand so much yappy dog. I'd have to have a synarctoides, and I'd also have to have an hydrocyon in order to be happy. I think I'd have to have them both, and they'd probably be best friends because they're both bone crushers of some kind. So that'd be what I'd have. 2 is probably my limit. 4 right now is a little much for me.
I see a new Netflix kids show in the works with this, and I really like that. So we'll see
That
what we
would
can do with that.
that would
Let's do
be
it.
adorable. I would love that.
All right, next question. And actually this one is for both you, Nick, and Amy, if you feel like answering. What's your story of how you ended up working at a national monument? Like it's, there are people out there who think like if you do that, you're going to be a park ranger or something, but
Mhm.
it's not really thought about that you can be a paleontologist at a national park or monument.
Yeah, it's actually Amy and I actually have fairly similar stories. But so I'll just tell my story. I won't tell it for her. But my story starts. So I grew up in Southern Oregon. I grew up around Medford, and there wasn't much in the way of natural history museums, but there was this place. And so I was a nerdy little kid, 8-year-old kid, being like, "Mom, I love science," and my mom was like, "Well, I also teach science among other things. So why don't we go out there so I can get you excited about science?" So he came out here when I was a little kid, and I was like, "Oh, this is so awesome!" And my mom learned there's a horse fossil trunk that we mail out from here for educators to use, and my mom was getting trained in how to use that when it first came out, and I was sitting there all excited, like, "Oh boy, this is so cool!" Like little 8, 9-year-old me is all excited. Um, and so that was like how I started. And then I found out later that there's a museum up in Portland that runs science camps in the National Monument, actually, up in the Clarno unit. And I went there as a kid and absolutely loved the paleontology camps I was a part of. And it's actually really funny now how many Hancock Field Station kids, former Hancock Field Station kids, you run into. Like Steve Manchester, who's a paleobotanist down at University of Florida, went there as a kid, and Amy and I both went there as kids, and another colleague of ours who runs the science camps at the Fort Hays State Museum was also there with us. Like it's just crazy how many of us are like out there and doing things. Um, and then I just kind of like stuck with it. I went to college and did geology and paleontology. Took a couple of years off. Then I went back and got my graduate degrees and stuck with paleontology. And it just so happened that this job opened at the right time. And I had done like some work at Badlands National Park. So seasonal work is really important. Doing internships is really important to work at a National Park Service site. And then getting in permanently, I just happened to have the right level of degrees at the right time when the job opened. So I will admit that there's a lot of luck that came into me getting into the position that I'm in. I mean, it's a lot more than just being at the right place at the right time and knowing the right people. There's a lot of other things, socioeconomic things that are involved with that also. But being a park ranger, I mean, that's the thing though, right? I mean, you can work for the Park Service and you can do just about any job, right? So like if you wanted to work at the Park Service, you could work as a maintenance worker, you could work in interpretation and education, you can work in resource management, even administration. I mean, we've got HR here and all kinds of business stuff, and believe me, there is so much paperwork working for the federal government. Right? So there is a lot of different kinds of opportunities, and one of the things that we like to say is that we're all park rangers, right, regardless of what our specific tasks and duties are. Like this badge says that I'm a U.S. park ranger, not a law enforcement ranger, but just a regular park ranger. So every time I put this on, I'm like, yep, I am a representative of this, and I am a park ranger when I'm here, and I'm also a paleontologist. I can be both things simultaneously. But I don't know
Multitasking.
if I don't know if you want to add anything about yours, Amy.
I was just gonna say that Nick was my camp counselor.
I
I've
was.
known Nick since I was
Oh,
like 8 years old. He used to be my camp counselor.
Yes.
And I think it would be a good time to do a shout out for, I know it was called Geoscientists in the Park when I did it, but the Scientists in the Park internship programs are great ways for especially students to get an opportunity to do internships and do a variety of different things. And it can be a great way to get your foot in the door.
Yes, absolutely.
oh, that's awesome. We'll be sure to put the links for that down in the description below.
Yeah.
So just a couple more questions before we wrap up. This one, we'll do a fun one and a little bit more seriouser question. But this one again is from Jasmine, who's asking, if you were a dinosaur, which one would you be? Nick, Amy.
A dinosaur? Well, birds are technically dinosaurs, so I would probably choose some kind of avian dinosaur personally, because I think that modern birds are really cool. That's probably not the answer you're looking for, but I do like the idea of being like I don't know, a red-tailed hawk or something like that. But if I were to choose like an actual like dinosaur, a non-avian dinosaur, oh, that's a really hard question to answer. I mean, I've always really liked therizinosaurs.
That was
Oh
mine.
yeah.
Nick.
So they're like these big sloth-like raptors, right? I mean, they're related to raptors, but they've got this big pot belly and they've got these big claws, and they're just like, I'm gonna eat leaves, and I'm like, this is like the ground sloths before ground sloths. These are really cool. Sorry,
That's mine. It's the Edward Scissorhands of dinosaurs, and I'm here
Yeah.
for it.
Perfect.
Yes.
I love it.
We're on the same path here.
We are.
I love it. Oh, actually, we got another question last minute. This one's from Grady, age 7. And Grady would like to know, how do you transport fossils from the field to your museum?
That's a really important question. So oftentimes, like when we bring it out of the field, like sometimes getting it off of the precarious perches that they're on, that's kind of a scary situation, and we have to like be really safety conscious when we do it. But once we get them down, and that can go from like putting it in a backpack and sliding it down a hill, using a cargo net. In really rare cases, like if we have no other option, just like pushing it. So we've got those options to get out. Sometimes we'd use helicopters actually to move fossils off of really hard to get to areas. But once we get them off of the hard to get to areas, usually we'll hike with them, or and oftentimes what we'll do too is if it's a particularly far enough away area, we just put them in the back of the truck and drive it here. It's usually not too difficult to do that. When I worked for the University of Nebraska, we did have to use a semi-truck to bring back a 1-ton jacket. We were working with the Department of Roads, and they offered to like haul it back from Western Nebraska to the museum in Lincoln. And so that was on a big semi-truck. But other than that, most of the time, our things are small enough that we can just throw it in the back of a sedan or not a sedan, but a suburban like vehicle, an SUV or a pickup truck, and bring it back.
Nice. Thank you.
Yeah.
I've actually transported fossils in my little sedan before, so you can do it if you need to.
Yes.
All right. So we're just almost up for time here on our special live stream. Thank you so much to everybody who's been asking questions. And if you have more questions, I recommend you follow our friends at the John Day Fossil Beds on their social media, Facebook, Twitter, Instagram. Am I missing anything, Nick?
Facebook, Instagram, and Twitter are primary things. You can also visit our website. We've actually got a really good video that orients folks to the park. But those are our primary ways of communication at this point.
All right, cool. We'll put links to those in the description as well. So, final question for today. When it comes to visitors coming to the park, and they can enjoy hiking and things like that, but what's the best way for them to support you when it comes to finding fossils when they're hiking, or even just supporting the museum itself?
Right. And I'm glad that someone asked that question. And so what I would say is, if you find a fossil out in the field, out in John Day Fossil Beds, leave it where it is, and come back and report it to a ranger. The best ways to do that is just like take a photograph, and if you got like a trail map or something, just like mark where you are. We do have a visitor site report form that we do have here at our front desk. So if the visitor center is open, you could come in and report a fossil that way. And that's generally the best way to do that, because we need that context information to make sure that those fossils are useful for science and in general stewardship of the future. So that would be the primary thing I would recommend. And like we've actually had a lot of people also who, when they found really cool fossils from places where they can legally collect, because remember in National Park Service sites you can't collect anything at all legally unless you have a permit to do so. And like if you're casually collecting on Forest Service land or Bureau of Land Management land or private land, and you find something really cool, it's really great if you can take that and donate it to a public repository. It doesn't necessarily have to be us, though I would love it if it was relevant to our fossil bed. Like we had someone donate a really cool rose stem a couple of years ago, and all it was just like a stem with some thorns on it. And it was one of the coolest things that I've seen donated to the park. And it was something that somebody had collected like 40 years ago when they were young. and we're out in this area before all the when it was a state park. And they're like, you know what, this is really important, and I want you to have this. And we're like, great, we're happy to have it here.
Awesome. Well, thank you everybody so much. Thank you, Nick and Amy, for that awesome tour today. We really appreciate it. And we really hope we can get more people to come visit the amazing John Day fossil beds.
Yeah, absolutely. We're open in the wintertime. We're open Thursdays through Mondays from 9 to 5. So someone will be here on those days all through the winter.
All right, I'm definitely adding this to my fossil road trip I'm gonna be taking soon. All right, thank you. Thank you so much, everybody, for tuning in. As always, if you like this program and want to support programs like it at the ALF Museum, you can find links on how to do that in the description below. National Fossil Day is brought to you by the National Park Services, and you can find more information on their website as well. And as always, make sure you like and subscribe to our channel for more stories from the world of paleontology. And we'll see you all tomorrow for Badlands National Monument. Bye, everybody.
Bye.